Today, we are tackling medication calculation questions, which are a guaranteed component of the NCLEX because they are a critical patient safety skill. Mastering a systematic approach is non-negotiable. While methods like ratio proportion work, dimensional analysis is the most reliable way to prevent errors under exam pressure. Let's walk through a typical high-level NCLEX problem. The order is for a pediatric patient who weighs 33 pounds to receive ampicillin 100 milligrams per kilogram per day, divided into equal doses every 6 hours. The pharmacy supplies a powder vial labeled 1 gram. The instructions say to reconstitute with 4.8 milliliters of sterile water to yield a final concentration of 200 milligrams per milliliter. The medication is to be further diluted in 50 milliliters of D5W and infused over 20 minutes. The exam question asks, what rate in milliliters per hour should the nurse set the infusion pump? First, ignore the distractors. The total amount in the vial, 1 gram, is extra information designed to confuse you. Focus on the final concentration after reconstitution. The most common error is failing to convert weight. The NCLEX almost always gives the weight in pounds when the dose is ordered in kilograms. Start by converting 33 pounds to kilograms by dividing by 2.2, which gives you 15 kilograms. Next, calculate the total daily dose. The order is 100 milligrams per kilogram per day, so 100 times 15 kilograms equals 1,500 milligrams per day. Now, determine the dose for a single administration. The order specifies every 6 hours, which is 4 times a day. So, divide the total daily dose of 1,500 milligrams by 4, which gives you 375 milligrams per dose. Now we need to figure out how many milliliters contain this 375 milligram dose. This is where our memorable phrase comes in: what you want over what you've got times the vehicle. We want 375 milligrams. What we've got is a concentration of 200 milligrams per milliliter. The milliliter is the vehicle. So, 375 divided by 200 equals 1.875 milliliters. Don't round yet. This 1.875 milliliters is then added to the 50 milliliter bag of D5W. This gives us a total infusion volume of 51.875 milliliters. The final step is calculating the infusion rate. The exam trap here is the time unit. The dose is infused over 20 minutes, but the question asks for milliliters per hour. You must convert minutes to hours. To do this with dimensional analysis, set up the equation 51.875 milliliters over 20 minutes, multiplied by 60 minutes over 1 hour. The minutes cancel out, leaving you with milliliters per hour. Calculating this gives you 155.625. The NCLEX will specify rounding, usually to the nearest whole number, so the answer is 156 milliliters per hour. By systematically moving from weight conversion to daily dose, single dose, volume to draw, total infusion volume, and finally the rate, you can navigate these complex problems and avoid the common traps set by the exam.